Hello guys, how are you doing? It's your boy Dave Partner. All right. Let's start with some competitive programming code. So we're trying to see if we can check if a number is a prime number. So any number that you're given, you want to write a code that will check if that number is a prime number. So to start with this solution, what we're going to look for is what is the definition of a prime number. So a prime number is any number that can only be divided by 1 and itself. Okay, every number on earth can be divided by 1. All right, any number divided by 1 is that number. So 100 divided by 1 is 100. Okay, so basically a prime number is a number that can only be divided by itself, and numbers below 1 cannot be considered in terms of division, so it has to be above. So if we're looking for a prime number, we're going to look for any number from 2. Okay, above 1 is 2, right? These are whole numbers we're talking about. Okay, prime number has to be any number from 2, all right, to that prime number minus 1. Okay, any number between these two. Because 1 can divide that prime number, we are not going to include 1 in the numbers we're searching, all right? And because that prime number can divide itself, we're not going to also include it. So we're going to start from 2 to the last number before that prime number. So if we want to check if 100 is a prime number, for instance, we're going to start from 2 and stop at 99, okay? Because we know that 100 can divide itself, so we'll stop at 99. So prime number minus 1. So let's write a simple Python code. I'm using Python. If you're using JavaScript or PHP or any other programming language, it's fine. I'm going to explain how to do that in that other language too. So if we, this is a code I've written that tells if a number is prime number. So before I explain this code, let's enter a number 12, for instance, and run this code. Okay, so if we have a number, I have to remove this return statement to start with. So alright, so this code now, if we run it, it says 12 is not a prime number because somewhere it found a number that can divide 12. Alright, so what if we say print the I can divide 12, can divide prime number. Okay, so here we're going to put I in string. In Python, you must make sure that everything inside a print statement must be of the same data type. So I'm going to put these as strings. So if we run this code again, it's going to tell us which numbers it found. Look at the numbers that could divide 12. Say 2 can divide 12, 3 can divide 12, 4 can. So therefore 12 is not a prime number. Nice code, right? So let's look at the code. This is a function in Python. So we define the function and passed in a parameter, and we set a variable so that this variable is just to tell us, so that we can have some output here. And then we have a loop. So let's talk about something called brute force. Okay, brute force approach. Brute force is a method in programming where you have a problem and then you have to iterate, okay, loop through a certain number of possible solutions, and for each loop you check if that your generated solution will work. Okay, that is what brute force in programming is. Any kind of algorithm that involves going through several different possible solutions and checking if they will work, okay, against the problem. Example, when a system is trying to guess your password, okay, they check through so many possible combinations, and that's basically a loop running. All right, so message is a prime number. All right, we just set it as a variable, and then we loop from I. In JavaScript, this is basically how to write a for loop in Python. In JavaScript or PHP, that would have been something like for. Okay, we do like I is equal to 2, right? We're starting from 2, semicolon, until I is less than the prime number you give us. Okay, that's basically prime number plus 1. Okay, let me make it easily. I equal to prime number minus 1. Okay, you have to put it inside a bracket, right? Prime number minus 1 has to be inside a bracket. It's the same thing with what I wanted to write before. Then you put semicolon and then you increment I, you say I plus plus. Like this. Then you write your code inside here. So this is how you would have written it in JavaScript or PHP or Java. Alright, but in Python uses something called range. Range, so we're saying from range, this is the starting point of the range, and the ending point is prime number minus 1 of the range. You know, in JavaScript, you could have written this, since we're dealing with whole numbers, we would have also written this like this, and say less than. You see, from I starting to 2, from 2 to I less than prime number, increment I in each iteration. Then every other code I'm writing here is the same. Okay. So this for loop is looping from 2. Remember, we want to loop from 2, all right, till the number less than, okay, the prime number, the last number less than, last whole number before that prime number. So for each iteration, remember brute force that we have to do iterations and then we check. So this is a check, an if statement. We want to check if that prime number it can be divisible by the current iteration. So the first time this loop is going to run, the current iteration will be 2. So we're checking if that prime number can be divisible by 2. So what is this percent sign? In case you don't know it, it's called modulo. Okay. So let me take a second or two to explain modulo. Modulo, that's what it is called. So this modulo operator is the percent sign. Okay. Just like the division operator is the / sign, okay, and the addition is the plus sign, okay, in calculations or mathematics. So what does addition do? It adds two numbers. 4 plus 4 equal to 8, okay. Same thing with division, it divides two numbers. 4 divided by 4 is equal to 1. But here, look, what modulo does is it does the division and checks the remainder, gives you the result of the remainder. Alright, so if we do 4, okay, let me put this up. If we do 4 modulo 4, it says 4 divided by 4, which is 1. Remainder what? 0. So 4 modulo 4 is 0. So let's try another one. If we do 5 modulo 2, 5 modulo 2 is what? 5 divided by 2, which is what? 5 divided by 2 is 4 remainder 1, right? So the modulo here is 1. So if a certain number during this iteration, if a certain number, we say, let's say we passed in 12, right? We say 12 divided by 2, which is 6, remainder what? 0. So that means that 2 successfully divided that 12, which means 12 is not a prime number. Okay. So that's what it is. Now this is just a function I wrote. There are many ways to optimize this function. For instance, this print statement can be outside the function itself. Here it is inside. In Python you use space. Look at indentation. That's what you use to know what is inside what. So the whole of this thing now is inside this one. Alright, this is a function definition. So it doesn't matter. I'm not about code accuracy here. Okay. So but I want to show you something. Now we've done this and we see that these numbers divided 12. What if we try 11? Okay, let's try 11. Run. It says 11 is a prime number. You see, because this condition never came true. All the numbers it tried between 1 and 11 did not work. Okay, or 1 and 2 and 10 did not work. Alright, that's why it says 11 is a prime number. So our code works so far. Now let's try some things, okay? Let's try and check how long it takes to run. So let's put an extremely large number. Let's say 10,000. 10,000. This is 10,000. 10 with 4 zeros. Now we are going to check time. So in Python I will import time, okay? Import time. And then I'll define time and say here, what's happening? Okay, 2 blank lines. Python, you need a lot of space. So we're going to start once the function starts and create time. So let's say start time equal to time dot time, like this. Okay, so we've defined start time. So we allow the function to run, and here we do end time. End time equal to time dot time. Okay, so after printing the message, we can now print that the time it took what time? We do string start time minus end time. Okay, plus again seconds. So plus. So basically, and then we run the function, right? So basically, I inserted time so I can check when the function started running, and after it has finished running, we also check that it has finished running. Why is it saying I have typo? All right. Okay. So let's run this function. It checks for 10. All this printing, we don't want this printing, right? We don't want this printing, so that our output will be simple. So that 10,000 is not a prime number. It took 0.001 seconds to run. Okay, 0.001. So take note of this. Okay, that's what it took to run this function. Now let's try another way to write this function, okay, and make it more optimal. Just another way. You know, I can actually close up these empty spaces, but I just left it so that it will be easy for you to read what's going on. This is supposed to be end time minus start time. Okay, the time it's finished minus the time it started will tell us how long it took it to run. So if we run, we get, okay, 0 into 4 places, then 73. 0 into 3 places, then 73.5. Okay, so let's note this. I'll copy this, right, and note it. First code seconds. Now, what other way can we find a prime number? Think about it. What other way can we get a prime number? All right. The other way we can get a prime number is that. Let me just show you this whole function before I comment it out. So this is what the function looks like. Okay, we imported time, we used time to check, we set message, and then we did a loop, and everything here is inside the loop. Okay, so inside the loop, first of all, everything here is inside the loop. Okay, so inside the loop, we simply checked if that number is divisible by the iteration, and then we print. Otherwise, we print the other message, and then we use this to check time. Good. Now we want to modify this. Now, in the definition of a prime number, remember I said any number that can be divided by itself and 1. So what are we checking here? We're checking all the numbers between 2 and that prime number. Okay, this is too large. What we're looking through is too large. For 10,000 now, we check between 2. If that prime number is 10,000, we check between 2 and 9,999. That's too many numbers. Now, in mathematics, we know simply that you can't find a divisor that is greater than half of that whole number or that prime number, okay? Here's what I mean. For each iteration here, what we're basically doing is we say 10,000, okay, divided by that iteration. So the first time we do 10,000 divided by 2, and the second time we do the second loop, all right? You know this is a loop. The second time we do 10,000 by 3, 10,000 by 4, like that, till we reach 9,999. And this denominator, which is 3, 4, whatever that we're looking through, in mathematics, you can't find any number greater than half of this that can divide this. So half of this is 5,000. So the last number that can divide 10,000 is actually 5,000. You get? So the last divisor, the last number that can divide any number you give me is half of it. So if you give me 10, the last number that can divide 10 is what? 5, because 5 is the half. So the moment you get to 6, 6 can no longer divide 10, right? So now we know that half, the numbers we're looking for should be half, right? So we can shorten this iteration. Instead of getting to n minus 1, or instead of getting to the prime number or the number we're given minus 1, what do? We get to that number divided by 2. That's the maximum we should get to. Alright? First, we'll have to improve this code a little, because sometimes you may get a number that will divide and end up with a decimal number. Okay? So for instance, if we're looking for numbers for prime, or whether we want to check whether 10 is a prime number, okay? Okay, so we want to check that whether 10 is a prime number. We can say 10 divided by 2. First iteration, 10 divided by 2 will give us what? 5. So even by now we know that 5 is not a 10 is not a prime number, because it gives us 5 remainder 0. So I'll say remainder 0. That's what our code is checking. So what of the next iteration? The next iteration will do 10 divided by 3. Okay, you see, it will give us somewhere 3 remainder 1. You see, basically it's 3.33, right? Something like that. 10 divided by 3. So this is decimal. So what do we do in this case? We'll round this number to 4. Okay, so we'll just do round 4, or basically seal 4, whatever. Okay, so we're going to try that here. Say, in case it finds a decimal, we increase it, right? We'll find the upper limit. Okay, another way to just round. This round here will make sure that any number we get, if it is decimal, it will convert it to the nearest whole number. If it is whole number, it will not do anything. Okay, so we'll remove this wrong code we did here, and now we can run again. Okay, so we'll do run. So where are we? Okay, now if we check the time we had, look at the time we had is 0 into 3 places, right? We now have 73 or 735. This one is 387, which is half. Okay. So a little optimization helped us to run this code in half the time. So what does this teach you? That when you are running a large code, let's say you are looking through to calculate the total number of amount that your customers are owing you in a certain platform, and you have millions of customers, just a tiny little knowledge of mathematics can help you optimize the code. So we just saved almost, if we remove all these zeros, I think it will be easier for some people to understand. If we remove all these zeros, we can see that 380 is half of 735. Okay, just about half, just about. So another thing is there another way we can optimize this code? All right, so if I say yes, there is, of course. Can you think of a way? This involves knowledge of basic mathematics. That's where you're going to get the tip. It's not that programming is mathematics, but a little knowledge of mathematics might help. So we've used the first one to find out that we need to split it into 2, okay, the divisors into 2. Now at the third code, let's look at this. If m, let's say a number, give me any number, and if that number can become a multiple of 2 numbers, okay, if I can do x times n. If any number is a multiple of 2 numbers, then that number is not a whole number. Here's what I mean. If you tell me that a whole number, that any number can be divided by another number that is not 1 and itself. Let's say you give me a number and I'm successfully able to divide it by 3 and the remainder is 0. Okay, if I'm able to divide it by 3, it means that 3 times a certain number will give me that number. Here's what I mean. So let's say you give me 10. You give me 10 and I start looping here to check. So I do 10 divided by 2. What does it give me? 5. That means 10 is not a prime number because there's a number between 2 and 9 that divided 10 successfully, which is 5. So what this also means is that 10 is equal to 2 times 5. That's what it means, isn't it? So if you give me any number and I can multiply any two numbers to get that number, that means that number is not a prime number. It's the same thing, right? So let us break this down into code. So let's say prime number. I should have used number, right? Whole number here instead of prime number, but it's okay. It's okay. You understand what I'm saying? So the iteration here is I. So we know we're looping, right? So we're using I as the loop. So we're saying for each loop, if that I can be multiplied, if X can be I times something. So, okay, that's what it means. Well, this is what we should check inside our code. Let's do some interesting math. So basically, let's say that the prime number we're given is 10. Okay, so 10 is equal to 2 times 5, right? 2 times 5. There are other ways to find out, but 10 is 2 times 5, all right? So when we are iterating, basically what we're saying is 10 divided by, so if we make 5 the whole number, remember that I called 5 something, and 2 is that I. So if we make something the whole number here, it's going to be, all right, prime number divided by I, okay, equal to something. Okay, if I reverse it, it's just going to be something equal to prime number divided by I. So this is basic math. In basic math, if you want to make something the whole number, you just take, and then there's a multiplication, you just take this one and put it under. Take this one and put it under. Once it crosses the equal sign, it changes from multiplication to division and vice versa. So now we have a formula for finding that something, okay? Because we know I, right, from the loop. Each loop tells us what I is, and basically what we're trying to say is here, divide that prime number by I, which is this. We're doing divide that number by I to get something and check whether there is a remainder. That's what we're trying to do here. Divide that prime number by I, get something, and then check whether there is a remainder. We're not taking account of that something, but the optimal way we want to write this code is to actually find that something. So now that something is equal to prime number divided by I, but that's not our end goal. An end goal is, in every multiplication, one number must be less than or equal to the other number. One number must be less or equal. So here's what I mean. If we're looking for 25, to check whether 25 is a prime number, 25 is what? 5 times 5, all right? So you see, it's equal. In this case, one number is less. So let's assume that I, which is the number we already know, we know I from this loop. Let's assume that I here is the lesser number, okay? So now they're telling you that here, I is also greater than, I is less than or equal to, that is I squared. How do I write squared now? Okay, let's write it like this. I squared is less than or equal to something, which is the other bigger number. So in every multiplication, one number is always less than the bigger number. That's the bigger number times the smaller number. Times I think I'll do that this way. Okay. According to maths, if two numbers are multiplying each other, all right, let's say 5 times 5 gives you 25, or 2 times 5 gives you 10. The lower number squared will always be less than the product of the two. So 2 squared here will give you what? 4. 4 is less than 2 times 5, which is 10. 4 is less than 10. You see? In this case where the numbers are equal, if we take the lesser one and square it, 5 times 5 squared is 25. You see, it is less than or equal. That's why I said less than or equal. So if you take the lower number and square it, it will always be, the lower number squared will always be less than or equal to the high number times the original lower number. You understand what I'm saying? So now this I here, we can actually replace I. We can replace something here by I squared, right? Instead of saying something here, I can do I squared. I squared. You understand? So it's that easy. Maths, this will be simple, but if you don't know maths, this might be a little confusing, but don't worry, when we get to the end point, it will be clear, all right? Because you just need to know the end goal, all right? And I'm just taking time to make sure that I show you. Now here, if you look at this, you see that this something times I is also the same thing as prime number. You see, prime number is equal to something times I, right? So we can say that the prime number is this way. We can say that I squared must be less than or equal to the prime number, because see, something times I is the prime number, right? We can say that I squared is less than or equal to the prime number. You understand? So if you give me 11, if you give me 10, I can say that I am 100% sure that 2 squared will be less than that number. That's what we're saying here. The lower of the multiples must be less than. All right? So what is this I squared we're talking about? We're saying that for each iteration, if we square the I here, the number that will divide that number, the prime number, the number that will divide it, will always be, if you square that number, it will always be less. That's what we mean. So for each iteration, if we square that number, the number that will divide it, it will always be less than the prime number. That's what we're saying. Okay, if we make that number, if we remove that square so that we don't have to write square here, right? If we remove that square and cross this square over, it will be square root, right? It will now be I equal to square root of the prime number. If you know maths, this is simple to understand. Okay, once a square, basically I squared is the same thing as I raised to the power 2, right? I'll write it like this. This is how you write it in programming. I raised to the power 2 is less than or equal to the prime number. Okay. Now if you make I the subject of the formula, it will now be square root. There's no way to write square root, so I have to write it as a sentence. Okay. But in programming, you will just do sqrt in bracket this way. So if there is any number at all that is going to divide this prime number, that number cannot be greater than the square root of that number. All right. So let's translate it into a code. So here we are looking from 2 to what? We can do 2 to the square root. Okay. 2 to the square root of that number. So square root. In Python, you can't just write square root like this. You have to import it. So import math. Okay. So here we can say import math. Okay. So now we have access to math.square root. So we don't have to loop all the way to half. Now we can just loop all the way to the square root. Here's what I mean. Let's find the square root of, let's use Google. Okay, so it will be easy for you to understand. So square root of 10 is 3, all right? We'll round it to 4 or round it to 3, okay? So if we look at our code, remember the first time, the way we looped here, we looped from 2 to prime number minus 1. So if we were given the number 10, we would have looped from 2 to 9, all right? And secondly, we found out that we can actually loop from 2 to 5. That is 10 divided by 2. Now we can see that we can loop from 2 to square root of 10, which is 3. You see? The number of such we're doing is now very low. Okay, so we can do that again and try out. So if we're given 10,000, we'll find the square root of 10,000 and loop from 2 to that square root. So how do we do that? So let's do the same thing for 10,000, right? We'll run the code and boom. Say it took this. So let's compare this number. Okay, it's not a prime number, so it took this time. So if we go here and check the time it took this, we can now see that third code or iteration, right, modification. If we remove these 4 zeros so that we can see it well, see? In simple English, what our code simply says is that if you are looping, alright, once you get to the lower number that could multiply whatever else number to get the prime number, once you get to this point, there's no point getting to these other points, alright? For instance, in the case of 10, once we get to 2 and we don't find if it is a prime number, there's no point getting to the middle way, which is 5. Remember, our second code got to the mid of it, simply saying that, hey, if you passed the square roots, there's no point getting to the middle to find it. You see how we moved from 735, optimized our code to 3875, and finally got it to 219. Okay guys, there's one more modification we need to make in our code, not for efficiency but for accuracy. Okay, so we put 10,000 and it was able to find that it's not a prime number. Okay, so first of all, if we wanted to print all the places, all the divisors of this number, like what made it not a prime number, we can just do what we did before, which is print is a divisor. Okay, so we want to print all the divisors in that number, so we'll give space here. Here's what I mean. We can say I is a divisor. Okay, so I'll put plus here. Make sure that it's wrapped in string str. So I'll use a low number so we can see it. Just use 10, and then we run. Okay, make sure there is a space here. So you say 2 is a divisor, but you know it stopped at 2 because 2 is the last number before the square root. Okay, the square root is around 3, and 2 is the last number. So we never got to 5. So this is a proof that we never, out of the 2 divisors of 10, which is 2 and 5. All right, we never got to 5. The moment we passed 2, we stopped. The code stopped. Okay, which is very efficient. Now another thing is, let's try something interesting. What if we put 0? We know that 0 is not a prime number. That's officially accepted in mathematics. Okay, so 0 and 1 are not prime numbers. So I'm going to prove it to you. 0 is a prime number. See, our code is wrong, telling us that 0 is a prime number. Is wrong. Okay, in programming it is called, this kind of case, a problem is called corner case. Corner case. Okay, a case that something that you did not consider, a special case, even though your code is running properly. A corner case is a special case that you did not pay attention to. Like you have to make a special if statement for it. Okay, that's what we're going to do. Now let's try 1 too. Let's try, is 1 a prime number? No. 1 is but our code is lying. It's saying that 1 is a prime number, which it's not. So to Google it, you see, I wanted to prove it to you before I implement what I want to implement. If we Google it, it says, is 1 a prime number? No. Is 0 a prime number? And no. What of 2? Yes. So we said any number between, alright, that can be divided by itself and 1. But negative numbers cannot be prime numbers too. Let's say is minus 1 a prime number. So negative numbers cannot be prime numbers. So any prime number must be between 2 and infinity. Okay. So we're going to update our code somewhere to take care of that situation. So if the number that was entered is between 2, right, is less than 2, no need to start checking whether it's a prime number or not. We should just conclude that it's not a prime number, right? So of course there are other ways you can do this. All right, so if, write an if statement that says if prime number is less than 2. Okay, if it's less than 2, then we do a code. We can just say message. Message is not a prime number. Okay, in your own case, it could be to return true or return false if you modify the code. Then otherwise, yes, otherwise do the rest of this. So otherwise, do the for loop. Okay, so we're trying to do the for loop only if the number is greater than 2. Okay, so in that case, let's start. Okay, we'll run the code here. Remember that the number we passed is 1. It says 1 is not a prime number. Now our code is thinking properly. 1 is not a prime number. And 2 is not a prime number. Now one more thing that is off limits. Okay, look at this. They said if a number is having for instance, a 2-digit number, right? If a number is having an even number as one of its numbers, then it's probably not a prime number. You understand? If a number is having a 2-digit number, an even number as part of it, it's most likely not a prime number. Okay, here's what I mean. If this number is not a prime number because it has even, this is not a prime number, this is not a prime number. Okay, let's check. Is 45 a prime number? That's interesting to check. It won't, because it can be divided by 5, right? So 45 is not a prime number because 4 has even. 4 is even. See, it has many divisors. So if a number has an even number as part of it, it's most likely not going to be a prime number. All right, so that's one of the tricks there. So this is it. You can get this on GitHub. Okay, just go to my page on GitHub. Just go to GitHub. If you're looking for this code, check in the description section below too. GitHub Dev Partner. You'll see it. I'll put the actual link in the description section below. Isn't that amazing? Now, if you're not this good in maths to know all these tiny little secrets, just remember that you can Google it. So if you are writing a software code that involves a certain calculation, you can Google how to solve this in maths. Alright, then you see it in maths. For instance, if you, in prime number, let's say you're writing a code that needs to find a certain prime number inside your software or platform or SaaS application, you can just Google it, okay, and then you read all the different maths formulas to find that solution, and then you implement it in your software. Okay, you implement it in your software. Look at what is the formula for a prime number. There's one we didn't even check. The 6n plus 1 or 6n minus 1. We did not check that. Okay, it's another method. You see, this one says method 2. Okay, so you Google and then you find the optimal mathematical solution, okay, or formula. Then you can see how you can implement it in your code, and you test the time. So that time is going to tell you whether your code is optimal or not. So we moved from 735, halved it, and almost halved it again. This is almost half. Look at it now. It's almost. If we round this up, this is 400 and this is 200. That's almost half. Alright guys, don't forget to subscribe to my channel, alright, for programming tips and tricks like this. Click the red subscribe button below, turn on notifications, and share this to programming channels so they can see. So if you're given this as an assignment, this is one of the most optimal solutions. Now, if you are able to come up with a solution that is far better than this in terms of time taken, right? Let me know, alright? Drop it in the comment section below. If you have any improvement on this, drop it, alright? Thank you very much, guys. See you.